What if I told you that right now, far beyond the planets, beyond even the most distant spacecraft we've ever launched, there may be a wall so enormous it could swallow entire star systems within its boundaries? Not a wall made of stone or metal, but of ancient icy worlds, frozen relics left over from the birth of our sun. Imagine a sphere of debris stretching so far that if you could travel at the speed of today's fastest spacecraft, it would still take you tens of thousands of years just to cross its edge. This is not science fiction. It is one of astronomy's most enduring mysteries, the Oort Cloud. When you step outside at night and look up at the stars, it feels as if space is an open, infinite ocean. But hidden in that darkness, surrounding everything we know, Earth, the planets, the comets we occasionally glimpse streaking across our skies, lies something like a cosmic fortress. We've never photographed it, and no telescope has ever captured it. And yet, almost every long-period comet that falls toward the inner solar system points back to this invisible boundary. It's as if the solar system itself is encased in a secret halo, a frozen bubble guarding its edge. Tonight, we're going to peel back that veil. We'll explore why scientists are convinced it's there, even though no eye has ever seen it. We'll uncover how an astronomer named John Oort, back in the mid-20th century, connected the dots and dared to suggest that a hidden shell of trillions of icy bodies must surround us. We'll retrace the clues left by wandering comets, investigate the staggering scale of this invisible wall, and relive the close encounter with a neighboring star that once brushed against its outskirts. In this journey, you and I will travel across distances so vast they make the planets seem like stepping stones. We'll compare the Oort Cloud to the more familiar asteroid belt and Kuiper Belt and discover how different, how otherworldly it truly is. We'll also confront a haunting question. If this structure is real, what role has it played in shaping Earth itself? Could the water in our oceans, or even the spark of life, trace its origins back to this distant frozen realm? This is not just a story about astronomy. It's about our place in the cosmos, about the boundaries that define us and the mysteries that wait just beyond them. Hello and welcome. I'm Orion, coming to you from Infinite Universe NTH. The invisible sphere of icy debris surrounding our solar system has a name, the Oort Cloud. It honors John Oort, the Dutch astronomer who, back in 1950, pieced together the clues that revealed its existence. When astronomer John Oort looked at the sky in the mid-20th century, he wasn't hunting for a pretty picture. He was doing forensic work. He gathered the orbits of long-period comets, icy visitors with paths so stretched that their periods aren't just centuries, but sometimes millions of years, and noticed two clues that didn't fit the inner solar system. First, these comets were arriving from every direction, not just along the flat plane where most planets and short-period comets live. Second, many of their orbits were almost perfectly parabolic, as if they were falling in from unimaginably far away, with just enough energy to be captured briefly by the sun's gravity. Oort realized that if you see arrivals from all directions, the source can't be a thin disk like the asteroid belt or the Kuiper Belt. It has to be a roughly spherical reservoir, a distant shell surrounding everything. That Oort spike in the data, the clustering of comets with extremely large semi-major axes, was his smoking gun. Picture our more familiar neighborhoods first. The asteroid belt sits between Mars and Jupiter, a few astronomical units from the Sun. The Kuiper Belt begins near Neptune at 30 AU and stretches out to 50 AU, a frosty ring of dwarf planets and debris. Now lift your eyes beyond any map we've ever drawn. The inner Oort cloud is thought to begin around a couple thousand AU, and the outer cloud may extend to $100,000 AU, about 1.5 light years. If the solar system were a city, the asteroid belt is the downtown ring road, The Kuiper Belt is the far suburbs, and the Oort Cloud is the quiet county line so distant you can barely find it on most maps. How did we end up with such a colossal halo? Roll the clock back 4.5 billion years. As the giant planets formed, they played gravitational pinball with countless icy planetesimals. Most were flung away, many escaped into interstellar space. But a fraction were nudged just right, not free, not lost, simply parked on enormous orbits and slowly rounded into a sphere by the gentle tugs of the Milky Way's tidal field and occasional passing stars. Over time, that diffuse population settled into two related zones in many models: a far-flung outer cloud and a somewhat closer inner reservoir, often called the Hills Cloud, named after Jack Hills, which may act as a long-term supply depot that refills the outer regions after stellar flybys shake objects loose. And every so often, a subtle tug, a distant star's brush, the galaxy's slow tide, or even the collective pull of the giant planets, tilts a member of this frozen archive just enough to send it gliding inward. That's why long-period comets appear from any patch of sky, like messages from the perimeter. It's also why short-period comets are different. They mostly come from the Kuiper Belt and scattered disk, their orbits trimmed by encounters with Jupiter and friends until their periods are less than 2 centuries. Different neighborhoods, different delivery routes. If you could stand on a tiny probe parked just inside the inner Oort Cloud, you wouldn't see a crowded snow globe. You'd see almost nothing. The sun would be a bright star among stars, the planets compressed into a single point of light lost in the glare. And the nearest icy body might be so far away you could cross the size of a planetary orbit and still miss it by a wide margin. That sparseness is the point. The Oort Cloud is vast, ancient, and exquisitely empty in any local sense, yet statistically rich enough to supply comets for eons. Here's a mental shortcut I like to use. Imagine the Kuiper Belt as pebbles on a beach, spread in a broad ring. The Oort Cloud is the thin mist hovering over the entire coastline, almost invisible, but present everywhere when you step back and see the whole shore. And here's a what if to keep in your pocket as we go. If a distant, undiscovered planet far beyond Neptune, the kind sometimes proposed to explain certain odd orbits, exists, its gravity might subtly sculpt which icy messengers we see, and when, tracing faint signatures on a structure we can't yet photograph. We can test ideas like that by watching the statistics of comets over decades, the same way Oort read patterns no one had noticed before. That's the beauty of this detective story. We're mapping a frontier we haven't physically reached by listening to the footsteps of visitors that fall from it. In a moment, we'll push the scale to its breaking point, because once you grasp how big this shell might be and how slowly even our fastest machines move, the numbers feel almost unreal. And yet they're the numbers that shape our sky, ape. If everything you've heard so far sounds impressive, hold on tight, because the real jaw-dropper comes when you consider just how far this hidden wall actually stretches. The Oort Cloud isn't a neighborhood a probe can casually visit in a few decades. At its farthest edge, it could reach nearly 100,000 astronomical units from the Sun. That's about 1.5 light years. Put another way, if the solar system were the size of a coffee cup, the Oort Cloud would be the size of a city block surrounding it. It's a structure so oversized that even our bravest machines barely register as having left the driveway. Think of Voyager 2, launched in 1977, a marvel of human engineering that has now traveled farther than almost any other human-made object. It has crossed the boundary of the heliosphere, past Pluto's orbit, and slipped into interstellar space itself. And yet, even at a relentless 56,000 kilometers per hour, it would still need roughly 3 centuries just to touch the inner rim of the Oort Cloud. To cross the entire thing, 30,000 years. That's not a typo, 30 millennia. Imagine, by the time Voyager 2 could emerge out the far side, human civilization as we know it today might be unrecognizable, or perhaps long gone. That's the scale we're talking about. And this immense size isn't just trivia. It has consequences. It means the Oort Cloud overlaps with the cosmic neighborhood of other stars. Our sun is not isolated. It drifts through the galaxy alongside hundreds of billions of others. Around 70,000 years ago, a faint red dwarf system, known as Schultz's star, swept past the outskirts of our solar system, grazing the outer edge of the Oort Cloud. At first glance, a small star drifting by might not seem dramatic, but consider the delicate balance. Trillions of icy bodies poised in the dark, held just loosely enough by the sun's gravity that even a slight tug could shift them. Numerical simulations suggest Schultz's star may have nudged some of those objects, bending their orbits and perhaps sending a few long-period comets on journeys that would eventually carry them toward our inner system. For our distant ancestors walking the Earth 70 millennia ago, such comets would have been omens written across the night sky, messengers from a cosmic encounter they never knew had happened. Now, expand that thought experiment. If a low-mass star like Schultz's can stir the Oort Cloud, what about heavier neighbors? The Milky Way is crowded, and over billions of years our sun has had many close passes. Each one could have subtly reshaped the cloud, ejecting some icy fragments into interstellar space, while capturing others from passing systems. That leads to an almost science fiction possibility. The Oort Cloud might not be purely ours. It could contain objects born around other stars, cosmic immigrants wandering for eons before being folded into the sun's invisible halo. Every time a long-period comet plunges toward Earth, it might not just be a relic from the dawn of our solar system. It could be an interstellar traveler carrying a completely different chemical fingerprint. And speaking of interstellar, in 2019, astronomers observed something extraordinary. Comet Borisov, the first confirmed interstellar comet, sailing through our neighborhood. Unlike Oumuamua before it, which was more asteroid-like, Borisov had a visible tail and composition that clearly marked it as cometary. Its chemical ratios didn't match typical solar system comets. It bore the imprint of a different stellar nursery, possibly around a red dwarf. Borisov was a rare, fleeting visitor, but its existence reinforces the idea that Oort-like clouds must surround other stars as well. If our solar system has one, why not Alpha Centauri or Vega, or thousands of others? Suddenly, the Oort Cloud is no longer just a local curiosity. It's a universal feature, a galactic common thread. To me, the most mind-bending part is this. We talk about the Oort Cloud as if it's one thing, but in reality, it might be constantly trading members with the rest of the galaxy. It's porous, leaky, evolving, a boundary and a gateway at the same time. Imagine if our maps of national borders were drawn not in ink, but in sand on a windy beach, shifting, overlapping, erasing, redrawing. That's the Oort Cloud. An invisible wall, yes, but one that breathes with the galaxy's rhythm. And in that breath, in those exchanges, could lie the seeds of comets that shaped Earth itself. When people first hear about the Oort Cloud, the instinct is often to think of it as a curiosity, a distant museum of frozen rocks that has little to do with us here on Earth. But in truth, its influence may have been written into our planet's story since the very beginning. Some scientists believe that comets, many of which likely originated in the Oort Cloud, delivered a significant fraction of Earth's water. Imagine that for a moment. The oceans that define our blue planet, the waves crashing on every shore, might trace their ancestry back to icy fragments that fell inward from the solar system's invisible boundary billions of years ago. It is a humbling thought that a reservoir so remote could have poured the seas that cradle life itself. But the Oort Cloud's role is double-edged. Alongside the gift of water and organic molecules, it has also been the source of comets large enough to reshape life in catastrophic ways. Long-period comets come screaming toward the inner solar system at high speeds, unpredictable and often unseen until they are already inbound. The Chicxulub impact, which 66 million years ago ended the reign of the dinosaurs and opened the stage for mammals, is thought by some to have involved an Oort Cloud fragment, an object nudged from the outer dark, accelerated by gravity, and aimed at Earth with devastating precision. So in a strange way, the Oort Cloud may have helped both destroy and create, wiping out one dominant branch of life while ultimately giving our own species the chance to emerge. There's another dimension to its impact, the way it connects our solar system to the galaxy at large. Every close pass of a star, every gentle tug from the Milky Way's tide, stirs the Oort Cloud like a cosmic mixing bowl. That means some comets that now orbit our sun may have been captured from other systems, while some of ours may have been donated outward long ago. Picture it as an interstellar marketplace, where icy messengers are constantly exchanged. Each new comet we observe could carry not only a physical fingerprint of chemistry, but a story of migration, of journeys begun around alien suns. And in those stories might be clues about whether the conditions for life are common or rare. For astronomers, the Oort Cloud is not just an edge, it is a lens. By studying the comets that fall from it, we glimpse the primordial material that built planets, the chemistry that seeded life, and the dynamical processes that knit our solar system into the wider galaxy. For dreamers and storytellers, it is something even more, a reminder that the boundaries we imagine are not walls of separation, but bridges of connection. The Oort Cloud is both a vault of ancient history and a highway for future discoveries, shaping the past of Earth and hinting at the destinies of worlds we have yet to know. And here's a thought that rarely gets mentioned. If comets truly are carriers of life's ingredients, then perhaps somewhere in the vast, dim shell of the Oort Cloud, frozen in slumber for billions of years, lie countless tiny capsules of possibility, biological seeds awaiting the right journey inward. We don't yet know if that is true, but the idea that the edge of our solar system could also be a cradle for future life is enough to transform this invisible cloud from an abstraction into something profoundly personal. The Oort Cloud remains unseen, and perhaps that is part of its enduring power. For centuries, astronomers have advanced human knowledge by trusting patterns, building models, and daring to believe in what cannot yet be directly observed. Copernicus and Galileo once described a heliocentric system without ever seeing Earth spin from space. In the same spirit, Jan Oort connected the dots of distant comets and revealed a structure so vast it reshaped our sense of the solar system's edge. History shows us that the absence of a picture does not erase the truth. Sometimes, the most important realities are the ones inferred with patience and faith in evidence. And as we stand here today, the Oort Cloud is more than a scientific puzzle. It is a mirror for our own lives. Just like the icy fragments waiting in silence at the boundary of our sun's influence, we all carry parts of ourselves that remain hidden, unmeasured, or unexplored. We can't always see the forces shaping us, whether it's the family we were born into, the society we live in, or the quiet pull of experiences from long ago. Yet, like comets nudged inward by distant stars, those unseen influences eventually guide our paths. The Oort Cloud reminds us that invisibility does not mean insignificance. For future generations, perhaps advanced probes or revolutionary telescopes will confirm this ghostly halo once and for all. Maybe one day, we'll hold in our hands a fragment from the cloud itself, proof that the farthest frontier of our solar system is also part of our origin story. Until then, it remains one of astronomy's greatest enigmas, a silent guardian encircling us, a frozen testament to time. The Oort Cloud reminds us that the forces shaping our lives are often invisible, quiet pulls we may not notice until years later. Just as comets from the edge have carried both water and change to Earth, the habits we build and the choices we make today can ripple forward, shaping tomorrow in ways we can't yet see. For many of us, that means slowing down, appreciating what truly matters, and trusting the unseen work we do each day. What unseen force has shaped your journey? Share your thoughts below, leave a like, subscribe for more, and until next time, peace and clear skies ahead. Thank you for joining me on this journey. I'm Orion, and this is Infinite Universe NTH.